The universe seems to be ruled by equations and numbers. But why just these equations and why just those numbers? Is it just a coincidence? Today I want to go through 7 of the weirdest coincidences in physics. Or maybe they're not coincidences at all. The first strange coincidence is the ratio between the masses of 2 particles, the proton, one of the constituents of atomic nuclei, and the electron. The proton is much heavier, and that ratio comes out to be about 1836. That's almost exactly 6 times pi to the 5. Coincidence? The second strange coincidence is one between the masses of 3 elementary particles. That's the electron and 2 heavier versions of it, the muon and the tau. If you sum up the masses and divide them by the square of the sum of the square roots of the masses, you get 2/3, up to a precision of 5 digits after the point. This is also known as Coides formula. Coincidence? The third strange coincidence has to do with a constant known as the Planck mass. The Planck mass is the mass associated with the strength of the gravitational force, that's 2 Newton's constant. It's the only mass scale you can construct from the strength of gravity. Max Planck was the first to notice that, which is why it's now named after him. If you multiply the Planck mass with the size of the universe and take the square root, you get approximately the cosmological constant. The cosmological constant is the simplest type of dark energy and determines how fast the expansion of the universe accelerates. It has no known relation to the Planck mass and certainly not to the size of the universe. So, is this relation just coincidence? The fourth strange coincidence has to do with modified gravity, or more specifically, modified Newtonian dynamics, MOND for short. MOND is the idea that the gravitational force law changes from 1/r squared to 1/r at a certain acceleration, usually denoted a0. This new constant a0 can be extracted from observations. You don't even have to believe in modified gravity for that. It's just data analysis. This acceleration scale is arguably there and comes out to be approximately the square root of the cosmological constant divided by 3. Coincidence? The fifth coincidence also has to do with the cosmological constant. The cosmological constant is often interpreted as a vacuum energy density. That is, it's the energy density of empty space if you take away all the particles. Strangely enough, this vacuum energy density is currently just about the same as that of dark matter, up to a factor of 2 or so. This is strange because while the cosmological constant is constant, the density of dark matter isn't. In the early universe, the density of dark matter was huge compared to that of the cosmological constant. Why would the two be just about the same size when we set out to measure them so that we can just about see dark energy take over? Coincidence? The sixth coincidence is known as the curvature problem, and it's similar to the previous problem. You see, space could have an overall curvature. That is, it might not be flat, but it could have a positive curvature like a sphere or a negative curvature like Pringles, and it could also do more complicated things like close back in on itself or what have you. This is all compatible with Einstein's theory. Now, if the universe starts out with a very small deviation away from zero curvature, then that curvature grows in relevance over the effect of matter and energy. That means if the universe had a very small curvature initially, then today that curvature would be huge, but it isn't. The universe, for all we know, is on average flat to good precision. So why was the curvature so close to zero at the beginning of the universe? Coincidence? And my 7th and final coincidence concerns the stability of our vacuum. You see, the vacuum of our space is determined by the properties of the Higgs field. Not the Higgs boson, but the field that's associated with it. Our vacuum is in what's called a ground state. That is, it basically sits in the valley of a potential. We know that much. But just how this potential looks like depends on several numbers, notably on the self-coupling of the Higgs and also on the masses of other particles. If the ground state was stable, the potential would look like this. If there are small fluctuations, it returns to its original state. The guys at CERN have been measuring these constants in the potential, and it turns out that our vacuum is not stable, it's metastable. This means it's stable for a very long time, but there are states of lower energy, and since there are always some fluctuations, our vacuum will decay eventually. What happens then is that this extra energy which our vacuum holds will pop up all around us, tearing everything apart. Don't get your hopes up too high though, it's probably not going to happen anytime soon. The expected lifetime of our vacuum is gigantic, something like 10 to the 500 years or so. Or to put this differently, it's very unlikely that it'll happen much sooner than that. But here's the funny thing. If the parameters were a little bit different, then our vacuum would be either unstable or stable. We sit in a small sliver of metastability. Coincidence? What are we to make of these coincidences? Well, one attitude that you can have is to say, there are so many numbers in physics, if you look for relations, you're highly likely to find something. Another attitude you can have is that maybe these seeming coincidences aren't coincidences, but they tell us that there must be a deeper explanation. Indeed, physicists have come up with many possible explanations for these coincidences. Unfortunately, so far, they've all been more complicated than just postulating the numbers, so they've all fallen victim to Occam's razor. But maybe physics is just waiting for you to explain it all. How many of those coincidences did you know already? And how many do you remember now that I'm done talking? Take our quiz to find out. Contrary to rumors, science isn't anywhere near ending. As you just saw, we have quite a few questions left to answer. And maybe you're the one to answer them. The best place to get started with your science revolution is on Brilliant.org. On Brilliant, you find courses on a large variety of topics in science, computer science, and mathematics. It's a fresh and new approach to learning that makes growing your knowledge easy and fun. All their courses come with interactive visualizations and follow-up questions. Some also have videos for demonstration experiments or executable Python scripts. This really gives you a feeling for what's going on. Whether you want to know more about solar panels, neural networks, astrophysics, special relativity, or computational biology, Brilliant has you covered. I even have my own course there. That's an introduction to quantum mechanics. It's a beginner's course and covers topics such as interference, superpositions and entanglement, the uncertainty principle, and Bell's theorem. And after that, you can continue learning more about quantum computing or maybe differential equations. To give it a try yourself, use our link brilliant.org/Sabine and sign up for free. This will give you access to everything Brilliant has to offer for 30 days, plus 20% off the annual premium subscription. Thanks for watching. See you tomorrow.